Okay, let's do the 11th problem. Okay, that is prove that this is equal to this. Okay, the left hand side is equal to the right hand side. Okay, and a condition is given that x belongs to minus 1 by root 2 to 1. Okay, close interval. And also a hint is given, that is put x is equal to cos 2 theta. Okay, so we'll take the left hand side, the tan inverse, and prove it to be the right hand side. Okay, let's prove it. Let's take the left hand side now. See, now if you see this resembles the property tan inverse tan theta. If this was some function of tan theta, okay, if this were tan theta, then this resembles tan inverse tan theta, which is equal to theta. So let's convert this to some theta. This to some tan theta. Okay, so here already it's given that x is equal to cos 2 theta. So let's put the values of x as cos 2 theta. Okay, now let's take the left hand side, that is tan inverse, and this will become 1 plus cos 2 theta whole root minus root over 1 minus cos 2 theta whole divided by root over 1 plus cos 2 theta plus root over 1 minus cos 2 theta. Okay, now if you see this 1 plus cos 2 theta and 1 minus cos 2 theta, this resembles a trigonometric formula, that is 2 cos square theta is equal to 1 plus cos 2 theta, and 2 sin square theta is equal to 1 minus cos 2 theta. Okay, so let's change this and this to these. Okay, let's put 2 cos square theta here and 2 sin square theta here. So it becomes tan inverse root over 2 cos square theta minus root over 2 sin square theta whole divided by root over 2 cos square theta plus root over 2 sin square theta. Okay, now let's split the square roots, the radicals, okay, between these. So it will become tan inverse root 2 cos square theta minus root 2 sin square theta whole divided by root 2 cos square theta whole root plus root 2 sin square theta whole root. Okay, now let's take the root 2 common. Okay, both in the numerator and the denominator. Let's take it common. So it becomes tan inverse root 2. Now see, this square and this square root get cancelled. Okay, here and here square root and the square. So we have root 2. We take root 2 common, so the remaining is cos theta minus sin theta. Okay, whole divided by root 2 cos theta plus sin theta. Okay, now the square roots get cancelled. You have tan inverse cos theta minus sin theta whole divided by cos theta plus sin theta. Okay, now let's take cos theta common. Okay, or instead of that you can divide all this cos and sin by cos theta. We can do both. Okay, so we'll do cos theta divided by cos theta. Okay, sin theta by cos theta whole divided by cos theta by cos theta minus sin theta by cos theta. Okay, so here this cos theta and cos theta get cancelled, here this get cancelled. So now sin theta by cos theta is tan theta. So you have tan inverse cos theta by it become 1 minus this becomes tan theta. Okay, whole divided by this becomes 1 and this becomes plus tan theta. Okay, now again this resembles a trigonometric formula. that is tan A plus B and tan A minus B. There are two formulas, okay? So we will use tan A minus B here. That is tan A minus B, which is equal to tan A minus tan B all divided by 1 plus tan A and tan B. Okay, this is the formula. Okay, now we have here, what we have is tan inverse 1 minus tan theta all divided by 1 plus tan theta. Okay, now we will use this formula. Now see, here we need something which represents tan A, but we have 1 here. Okay, so instead of 1 we have to put a value which represents tan A. So you all know that tan 45 or is equal to 1, or tan 45, instead of tan 45 you can write tan pi by 4. Tan pi by 4 is equal to 1. Okay, so instead of 1 we'll put tan pi by 4, and here we'll multiply tan theta with 1. Okay, so 1 into tan theta is tan theta. So now wherever here and here we'll apply pi by 4. So this becomes tan inverse tan pi by 4 minus tan theta all divided by 1 plus, now again here instead of 1 we put tan pi by 4 and tan theta. Okay, now this resembles this formula. Okay, this is exactly the formula, this expression. Okay, so we can write it as tan A minus B. So this can be written as tan inverse tan pi by 4 minus theta. Okay, which is exactly tan A minus B. Okay, now this expression has been simplified to the property. Now you can see this resembles the property, that is tan inverse tan theta, which is equal to theta if theta belongs to the range of the tan inverse, that is minus pi by 2 to pi by 2. Okay, so this, now here this is in the place of theta, so this expression can be tan inverse tan pi by 4 is equal to this according to this property only if this exists in the range of the tan inverse. Okay, so this will be pi by 4 minus theta if this is in the range of the tan inverse. So let's find out whether this exists in the range. Okay, now we have simplified this, and all along we came up to here, and we got pi by 4 minus theta. Okay, pi by 4 minus theta. Now let's find out whether this is in the range of the tan inverse. Now here they have been given a condition, that is x belongs to minus 1 by root 2 to 1 by 2. Okay, let this be here, x belongs to minus 1 by root 2 to 1. Okay, or x is less than 1 and greater than minus 1 by root 2. Okay, now we have taken x is equal to cos theta, cos 2 theta. Okay, so let's put x is equal to cos 2 theta. Okay, so cos 2 theta less than equal to 1, which is greater than minus 1 by root 2. Okay, now we have to find out this, whether this exists. So we'll start from theta. Okay, to find. Okay, now here we have to take check theta. So let's do step by step. Let's take first 2 theta. Okay, so 2 theta less than equal to cos inverse 1, which is greater than cos inverse minus 1 by root 2. Okay, now the principal, now we'll see the principal value of cos inverse 1 is 0. Okay, cos is 1 at cos theta is 1 at 0 degree. Okay, so 0. Now see the degree, okay, the domain of cos inverse and the values go in the opposite direction. Okay, one is increasing, other will be decreasing in the direction. So we have to change the inequality sign here. So this is 0, so 0. Now 2 theta is greater than 0. Okay, 2 theta is greater than 0, which is less than principal value of cos inverse minus 1 by root 2. The principal value of cos inverse minus 1 by root 2 will be pi minus pi by 4. Okay, so this will be how much? 3 pi by 4 greater than 2 theta, which is 2 theta less than 0. Okay, 2 theta is greater than 0 and this is less than 3 pi by 4. Okay, you know that cos theta, the range of cos is from 0 to pi. Okay, so this is the range where 2 theta exists. Okay, from 0 to 3 pi by 4 here. Okay, now so now we got 2 theta. Now let's check theta. So 2 will be gone to the right, 0 by 2 and 3 pi by 4 by 2. Okay, so this will become 3 pi by 8 and this will become 0. Okay, so we have 3 pi by 8 greater than equal to theta, which is greater than 0. Okay, now this one will change to this. Now pi by 4 minus theta, we found theta. Now we have to find pi by 4 minus theta. So let's add minus to theta. Okay, so minus theta. Now minus theta is less than 0, so the inequality changes again. In less than equal to 0, which is greater than minus 3 pi by 8. Okay, now let's add pi by 4 to minus theta. Now pi by 4 minus theta, and here also pi by 4 minus 0, and pi by 4 minus 3 pi by 8. Okay, now this becomes minus pi by 8. When you take the LCM of this, you will get minus pi by 8 less than pi by 4 minus theta, which is less than pi by 4. Now you see the range of pi by 4 minus theta, pi by 4 minus theta belongs to minus pi by 8 to pi by 4, close interval. Okay, if you see the ratio circle, okay, you will see that pi by 4 is here 45 and minus pi by 8 is in the towards the negative direction. Minus pi by 8 is here. Okay, so pi by 4 minus theta belongs here. Okay, which is in the range of the tan inverse, that is pi by 2 to pi by 2. This is the range of the tan inverse and this is inside that. Okay, so we can say that pi by 4 minus theta belongs to this, and also tan inverse tan pi by 4 minus theta is equal to this. Okay, so it's in the range. So we can say that pi by 4 minus theta belongs to minus pi by 8 to pi by 4, this one, and which is also a subset of this one, minus pi by 2 to pi by 2. Okay, so therefore we can say the tan inverse tan pi by 4 minus theta is equal to pi by 4 minus theta. Okay, so we got this pi by 4 minus theta. Now let's put the value of theta here. So here we know that x is equal to cos 2 theta, x is equal to cos 2 theta. So 2 theta will be cos inverse x. Okay, cos inverse x is equal to theta, or theta is equal to cos inverse by 2. Okay, so let's put the value of theta here, that is cos inverse x by 2. So we'll get pi by 4 minus cos inverse x by 2. Okay, now this can also be written as pi by 4 minus 1 by 2 cos inverse x. Okay, Now this is what we have to prove. This is the right hand side. See, pi by 4 minus 1 by 2 cosine x. This is it. Okay, so we have proved it. This is the right hand side. That's it.